Thanks for watching this ASNA video. I'm Roger Pence, and in this video we're going to start a series of articles/videos on programming AVR for .NET with classes and object-oriented techniques. This is a rich, deep subject, and it's going to take several articles and videos to cover it. Unlike AVR Classic and procedural languages such as RPG 400 and Ali RPG, AVR for .NET is built on an object-oriented foundation. While you can build a good application in AVR for .NET without understanding and using its OO capabilities, to make a really great application, one that is easy to test, enhance, modify, and maintain, you'll need some OO techniques in your programming kit bag. So this first article will introduce using classes with AVR for .NET. This video accompanies the article that you see in the URL shown from our knowledge base up on the ASNA.com website. Let's get started. I've got Visual Studio 2013 currently loaded on this virtual machine. We're going to start a Windows application. Now, I would prefer to do this with a console application, but I realize that even with a console application, you need to know a little bit about some interesting OO techniques that we're going to put aside for now. So we'll just do a Windows form application. I think that's sort of familiar to everybody. And we're going to call this class, let's call it OO Intro 01. Now I don't need much of a UI here. I'm just going to put a button on there. That's really all I need. We mostly want to see code. We don't want to see UI in this. Let's run that, see if that works okay. It does. There it is. Now let's consider this application just for a minute. We'll look at its code. Now notice that first of all, you can't escape using classes in AVR for .NET. They're everywhere in AVR for .NET. In many cases, they're sort of implicitly used behind the scenes, and you don't think too much about the object-oriented gobbledygook that goes with a class and OO and all that stuff. Classes are the fundamental building block of an application in AVR for .NET. They provide a bounded fence, if you will, around variables and actions. They encapsulate things. We'll see that in action as we go along. Now, typically, for an early beginner in AVR for .NET, it's not uncommon to see a substantial code behind. In this case, we've got Form 1 VR is the code behind that form. It's not uncommon to find 3, 4, 5, 6,000 line code behinds in either Windows programming or web programming. That's probably not the best thing. You end up with an amalgam of code that does database I/O, that does user interface manipulations, that does business logic, and it's all wadded up in this big ball. So one of the things that we want to be able to use these OO techniques for, in fact, I think the biggest thing we want to use these OO techniques for, is to partition these applications appropriately. So let's add a class to this project. I took a break in the video. You might notice it because I noticed that when the Solution Explorer was showing, the context menu was showing off the video recorded area. So I moved it to the left. That's what that break was, if you noticed it. So we're going to add a class to this project. So we'll come down to here. Now we can skip new item because there's an entry right there for class. So we'll say add class. It wants to know the class name. I'm going to call this class name sales data. .vr. It would put the VR there for you if you didn't use it. A couple of conventions. It's generally a good idea to have that class name match the file name. That's a pretty strong convention. And it's generally a good rule of thumb to have one class per source member. That's not a hard and fast rule, but it's a general guideline. Usually you'll have one. Now we'll discuss namespaces later in this video series. We're just going to kind of go with the flow on the namespace and kind of assume that it's there and we're happy about that. We are, but we'll get more into that later. There's a lot to talk about there. So now we have a class named sales data. I'm going to add a couple of members to it. I've got them hidden off the screen so I can just paste them in. So there's what we want our class to look like to start with. Now there's a couple of things here that I think are pretty obvious. One of them is that we have two that are public and one that's private. Those that are public can be seen by the outside world. Those that are private cannot be. The default is private. We could have omitted this. Now another thing you'll notice is my use of the declare prop keyword. You might be familiar with the begin prop keyword. That was a more verbose definition and declaration of a property. We're going to use declare prop right now. Declare prop will let us get and set that value from outside the class. You'll see this in action here in a moment. We've also made our class public. That means this class can be seen by the outside world. I don't think there's anything else too interesting or scary about what's going on here. Now in this case what we're doing is we're pretending that our app needs to track sales and returns and then have a private variable of rank. We're just going to kind of use him to show why privates don't show up here in just a minute. Think about this being a data structure of sorts, and you may have used an old school declare DS data structure in AVR for .NET. All right, let's use this class over there from our code behind. So in our button click, that's where we'll use it for now, just for lack of a better place to use it. Now to use a class, you have to instance it. So I'm going to declare a field, SD, type, sales data. Now if we use some IntelliSense here, we're going to be able to see there's our returns and there's our sales. Those are those two public properties. Notice nowhere in here do we see rank. Now remember we had a rank right there. That rank's private. It's not seen by the outside world. So this is a concept that you can read about in OO textbooks where they talk about data hiding or encapsulation. Now if we were to say SD sales, use IntelliSense, equals 400. Let's run this program and see what happens. We get this little pause and then we get an error. Object reference not set to an instance of an object. With OO and with using classes, you are responsible for bringing that class to life. You know, in RPG 400 or Ali RPG, when program A calls program B, there's an imaginary concierge that magically makes program B come alive for you. That's not the case in object-oriented programming. You need to explicitly bring it to life. A way to bring a class to life is to say new. You know, let me show you one more thing here. Before we put that new there, let's put a breakpoint here. The value of SD is nothing. So you can see that the value is nothing. We have not brought that class to life. Now let's run it again by putting that new in there. And now we'll see that the value is this class. And you can actually even look at it in the debugger and we can see sales and returns are set to 0. That's good. So if we press F10 to skip past. Well, something bad just happened. I pressed F10 to step over that breakpoint. And F10 is also the function key, hotkey, associated with Camtasia to tell it to stop recording. So let's get back to where we were. If I press F10, we can see here, if we hover over that, we can see that returns and sales are 0 and 0. If we press F10, we can see there's our sales filled out to 400, and returns would also do likewise. So let's go ahead and put returns in there. Let's say it's minus, let's use the numbers I used in the article, 45 and minus 17. So there we go. Now this is effectively a data structure. Let's look at it one more time. Press F10. Hover over it, and we can see that we've got our data structure, quote unquote, populated with those two values. That's great. Now at this point, it's really not that different than a data structure. But let's see that one of the differences is that we can pass this around. Let's also see one of the scary parts about passing it around. I'm going to copy a subroutine here. Pay close attention to what happens here. This might surprise you. You probably know that if you pass something by default to a subroutine or function in AVR for .NET, it doesn't change. It's passed by value, and its change is not seen in the caller. Let's see that very quickly. We're going to say and we'll say x equals 56. Now let's change this just briefly to say, we'll comment that out, and we'll say y, just for the fun of it, just because we can. Integer 4, and we'll say y equals 57, not 56. Test by val x. Now, I think you probably know this. Let's get rid of this for a moment. So we just have a subroutine that we're calling, and we're passing x to that subroutine. Now, you know, variable names don't have to match, and I kind of did that on purpose. By default, x gets passed to test by value. That means changes that happen here won't be seen in the caller. Let's prove that. Let's put a breakpoint here. Press F5. X in the caller is currently 56. We just called test by value. I pressed F10. X is still 56 in the caller. Now let's look at the interesting behavior when we pass SD down there. Well, how do you pass SD? You pass SD this way. So notice that I'm passing the SD variable. So for all intents and purposes, an instance of a class, that's SD in this case, is a variable. And we can pass it around. Notice that I'm declaring it as a type sales data. That's what it is. Generally speaking, the name of the class is, for all intents and purposes, a type, just like an integer or something. But in this case, we don't have to get too worried about it. But it is a type. Now watch what happens here. Remember, by default, AVR passes values by value to routines. So I'm going to step through it this time. We know that SD sales is currently what? It's currently 45, right there. We step into this guy, say SD sales is 55. That shouldn't bother us too much because we know it got passed by value. But look, it's 55. Let this soak in. When you pass an instance of a class to another member, it's always passed by reference. Now you think you can trick it, and you might try to do this. You might try to say, well, let's pass it by reference. Well, that would look like this. And we'll call this guy ref, and we'll say by. Now you could do this with an integer or a scalar numeric type, and it would do what you expect. It would change it. The caller would see the change. In this case, though, if we say test by ref, we'll comment this guy out. So now in this case, we are explicitly passing by reference. Remember before, when we called this, it was by value. So here we passed by value, and it changed it. Well, here we passed by reference, and you might expect it to change it in this case, and it will. Watch what happens. Uh-oh. Oh, because when I'm passing by reference, when this guy says by reference, now this signature doesn't match, so I've got to do this. I've got to say that argument is by ref, passing it by reference. Let's run it. So now we're going to pass by reference. We'll step down. Down there, SD is going to be 55. There it is. And when we return, sure enough, up there, SD is 55. So the first thing to let soak in on these classes is that when you pass them around, it doesn't matter if you declare it by reference or by value, you're always passing by reference. And when you pass a class around with public members, anybody in the world can change them. That's good and bad. It's good because you can pass a great deal amount of data around without much impact on performance, because you're not really passing around a whole bunch of data. You're just passing around a reference to that data. All right, so let that soak in. We cover that in the article. The other thing we cover in the article, and we're almost done with this video, is given this class here, this class only has data. Typically, the purpose for OO is to bundle data and like actions, associated actions. So let's add an action. In this case, what I'm going to do is add a function to the class. That function is called getNetSales. So look what it does. GetNetSales is type pack 12,2. It's public. So it's a function that can be called from the outside world that returns sales and returns. Now, there is a kind of an unusual thing going on here that we'll discuss later. We'll get to this guy here in a little bit in another video. This returns to this instance, refers to this instance of this class. That's probably a little gray right now. Don't worry about it. Technically speaking, we could remove the this and it would still work. My coding convention, my personal coding convention is to put it there. But it would find sales and returns because they're sort of global to this class, so it would find it that way. So that would work too. But let's put them back. That's really the way you want to do it. It's probably fuzzy right now. We'll get to that in another article and another video. Now we go over here to this side, and now what we can do is say, what did I say that length was? 12,2. So now we can say net sales equals SD. And notice now we've got a method called getNetSales. It is a method, so you got to put the parens at the end of it. And now let's run it. Oh, I forgot to put a breakpoint, pardon me. Now let's run it. And we'll see that net sales is 0. If I press F10, we'll see that net sales is 28, 45 plus minus 17. Now we can also do something else with this. It's pretty interesting. Let's run that again. And we can step into that class. So there we are, stepping into that. Now in this case, this method, this public method, public action, is pretty simple. But in the real world, it'd probably be some kind of complex action doing something and returning a value. So think of this sales data as a black box. It may have several private variables, private functions. It may have several private things, and its job is to package something up and effectively export it out of that sales data class. Now, there's a lot of things that we need to go over later. We discussed this briefly. We discussed calling the net sales. So that's really as much as we want to cover in this class. We're going to try to hold these videos to 15 or 20 minutes. But to recap, what we looked at was adding a class to a project and then using it, and how no matter what you do, pass by reference or pass by value, you must remember that when you pass an instance of a class around, it effectively behaves with pass by reference semantics. So you've got to be able to understand that public values may change. That's generally a good thing, but you do need to know about it. Now later, by the way, we'll also see how to package this class up into its own DLL so that it would live outside of this project. But for now, to get our feet wet, we're going to leave them inside the project. We'll cover that in another video too. So that's it for this Part 1 Introduction to Classes with AVR for .NET. Visit this URL to see this video in writing. And we'll check back with you later for Part 2 of using classes and OO techniques with AVR. Thanks for listening.